Lesson 5.3 is called Sum and Difference Identity. And we're going to talk about sum and difference identity for cosine. And we will look at the formulas and examples about this formula. Under 5.3, we need to learn that if you're trying to find the cosine of sum of two angles, the formula we will need is cosine of the first angle times the cosine of the second angle minus sine of the first angle times sine of the second angle. Similarly, if you're looking for the cosine of A minus B, then we will need the cosine of the first angle times cosine of the second angle plus sine of the first angle and sine of the second angle. So the first example we're going to look and use this formula will be, we're looking for cosine of 15. And cosine of 15, we're going to try to find its value without using a calculator. So since 15 is these two famous angles, 45 degrees and 30 degrees, the difference between 45 and 30 is going to give us 15. So if we don't have access to calculator or we want to find the exact value for cosine of 15, we can find cosine of 45 minus 30, which the formula says cosine 45 times cosine of 30 and then plus sine 45 times sine 30. So there's a mistake with the book work here. This one over here, sine 30, not cosine. So what it means is now cosine 45 is root 2 over 2 and cosine of 30 is root 3 over 2. Sine 45 is root 2 over 2. And then we also need sine of 30, which is 1/2. When we multiply these two things, the numerators will be given 2 times 3, which is radical 6, and 2 times 2 is 4. Here, I'm going to get square root of 2 over 4, and this answer is correct. But if my math lab requires you to write this answer as a one single fraction, you can also combine root 6 and root 2 in one fractional notation with a common denominator of 4. This will be the expected answer for cosine of 15. And this is how we use the difference formula for cosine. We have another example here. So what if the angle is in radians, for example, like 5 pi over 12? For 5 pi over 12, when we need to find the cosine of 5 pi over 12, if we think that 5 pi over 12 is sum of pi over 6 and pi over 4, because when you get them in common denominators, which is 12, you just have to multiply this one by 2, this one by 2, this one by 3. So this one will be 2 pi, and this one will be 3 pi. That makes total of 5 pi, and the common denominator is 12. So when you need cosine of 5 pi over 12, you can think that you will just calculate cosine of pi over 6 plus pi over 4. Using the formula, you can extend your equation to this format. Now, cosine of pi over 6. As you know, pi over 6 is 30 degrees. If that makes it easy for you to remember the values. So cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. And sine of pi over 4 is root 2 over 2. Again, these two will give you root 6 over 4. And these two will give you root 2 over 4. And if you want to write it as a one single fraction, this will be the expected answer for this question using the sum formula for cosine. This is my favorite question type for this lesson. So when we need to find the answer for cosine 87 times cosine of 93 minus sine of 87 and sine of 93, and let's say we don't have access to calculator, so we cannot plug it in. But we know that this looks like cosine of one angle times cosine of another angle minus sine of the first angle times sine of the second angle. And then if you remember the previous slides, this is actually cosine of A plus B. So we can just focus on that. This whole long thing is just the same thing as cosine of A plus B, where A is the first angle, and in this case, it is 87 degrees, and B is the second angle, which is 93 degrees. So this whole thing will just return us cosine of 87 degrees plus 93 degrees, which is cosine of, if we add these two angles, That's going to give you a 180 degree. And remember the unit circle, this is where 0 degrees, this is where 90 degrees, and this is where cosine 180 degree is located. So on the unit circle, the coordinate here is x value is -1, y value is 0, and cosine is the x value. So cosine of 180 is just equal to a -1. So this whole thing is going to return us a -1. And we got this answer by knowing the fact that cosine of a plus b can be calculated using this formula. For this lesson, we have one more question type that we're going to study. If sine of angle C is given this, cosine of angle T is given like this, both angle C and angle T are in quadrant 2. This information is important for the sine. We're going to find the cosine of S plus T. So cosine of S plus T will be calculated using the formula. And the formula says that you will need the cosine of the first angle and then cosine of the second angle. If you are finding the cosine of the sum of these two angles, then the formula calls for a minus, and then sine of the first angle and sine of the second angle. So here, cosine of S is not given, but sine of S is given. So to get this cosine of angle S, we're going to draw a right triangle, and then I will place my angle S. I will use this given information since sine value is given as 3/5. 3 is the opposite side, 5 is the hypotenuse, and I need to find this missing side using the Pythagorean theorem, and I will know that it's a famous triangle, 3, 4, 5 triangle. So now I can calculate the cosine of angle S, which is adjacent over hypotenuse, that's 4/5. But in quadrant 2, cosine value is negative, so I will need a -4/5 for cosine of angle S. Now, cosine of T is given in the problem, so I don't have to try to find it, so I'm just copying this. Sine of angle S is given as 3/5, and then sine of angle T is missing, so I'm going to draw another right triangle for angle T this time, and then this is the angle T. Its cosine value is given as 12/13, so adjacent side is 12, hypotenuse is 13. Using the Pythagorean theorem, we will find out that its missing side is 5, because 5, 12, 13 is another famous triangle. And sine means opposite over hypotenuse, so the fraction I need is 5/13. I just have to make sure that I'm getting the right sign. In quadrant 2, sine value is positive, so I'm going to keep it positive. Now, after finding out everything we need to apply the formula, the rest of them is just simplification. If we multiply these two fractions, negative times negative is positive, and now 4 times 12 is 48, and 5 times 13 is 65, minus 3 times 5 is 15, and 5 times 13 is 65. When we subtract these two numbers, we will get 33 out of 65 as an answer. I will try to simplify this, but I know that this is only divisible by 3 and 11. 3 doesn't work here, and 11 doesn't work here, so I'm going to leave my answer just like this here. And then this is the end of 5.3. So let's take a look at our homework questions now. For our 5.3 homework, we have 13 questions. And then the first one is matching these equations with the given formulas on the top. It's pretty easy. Cosine of x plus y is just a formula application, and its formula is cosine of x times cosine of y minus sine of x times sine of y. And then this one, again, this second question is exactly the same, but the sign changes from minus to a plus. So this is what I'm going to need for question 2. This one, we're going to actually apply the formula, and then we're going to find the cosine 90 and sine 90 and simplify it. So what I'm saying is, because there's nothing directly available, we will need cosine pi over 2 times cosine of x. But cosine of pi over 2 is 0. So, and then multiplying 0 by anything just gets us a 0. So we will need a 0 minus. Then we will need sine pi over 2 and sine x. And since sine pi over 2 is just 90, I will just need a plus sine x here for this question. To answer number 4, we will need the formula for that question. So I think it might be a good idea. You also copy the formula for sine, sum, and tangent formulas for this. So let's take a look at how to find the cosine of 75 from one of our homework questions. So if we think that 75 is sum of 45 degrees and 30 degrees, we're going to change the problem as first cosine of 45 degrees plus 30 degrees, because 45 plus 30 gives us just 75. And now, after we figure this out, we know that we can apply a formula to find the answer for this. And the formula says we need to use cosine 45 and cosine 30. Then we need to use a minus. And then we need to use sine 45 and sine 30. And as of now, we should already memorize the value for cosine of 45 as radical root 2 over 2, like root 2 over 2. And cosine 30 is root 3 over 2. Sine 45 is root 2 over 2. And sine 30 is 1/2. This is almost like the question we did on the slide show before the homework problems. Root 2 times root 3 gives me a radical 6. And then 2 times 2 is 4. Here, root 2 times 1 is root 2 over 4. So simplify your answer, including any radicals, and rationalize all denominators. So on the homework, I will just give them the expected answer is radical 6 minus radical 2 all over 4 for this question number 1. For number 2, we need to find cosine of 105. So the first thing I need to do is 105 is sum of what two angles? And when I think deep enough, I know that 105 is 60 degrees plus 45 degrees, because if I add these two famous angles, they are going to give me cosine 105 degrees. Now we have a formula to evaluate this, and the formula says we will need cosine of 60 times cosine of 45 minus sine of 60 times sine of 45. So first, this question comes in parts. So we're gonna just choose this, because this is what cosine 60 times cosine 45 minus sine 60 is sine 45. The rest of the work, I'm gonna leave it to you, because you're just gonna find out that cosine of 60 is equal to 1/2. And cosine of 45 will determine as root 2 over 2. And we will need sine 60, which is root 3 over 2. And sine 45 is root 2 over 2. Paying attention to PEMDAS, multiplication is first, then subtraction, you can find the answer to question 2. For question 3, we have this problem, and it wants us to recognize this expression is going to return equal to the which of these, and then we're going to find the answer. So when I look at the problem, first angle is 63, second angle is 27, and because the formula is using a minus, I know that this formula is about a plus b. So if you add the 63 and 27, the angle is 90 degrees. And this is the formula for cosine of a plus b. So I know that this whole thing will be equal to cosine of 90. So this will be chosen from these 4 options. And then once we know that this is equal to a cosine of 90, then we know this value from the unit circle, we can just type the answer and we can be done with question 3. So question 4 is very similar, but it just doesn't come in parts. We're just going to recognize that this whole thing, because it's a minus again, and it starts with cosine A times cosine B, this is a formula for cosine of A plus B, and A is 37, and B is 53. So when we add the 37 and 53, that's a 90 degree again. And now cosine of 90, we know the answer for cosine of 90. We can just type into the box and we can be done with number 4. This question, we studied it with the presentation, and we know that 15 is 45 minus 30. And this allows us to use the formula as cosine of 45 times cosine of 30 plus sine 45 times sine of 30. And then we can plug in the values from the unit circle, organize our answers, and we can find the answer to this question. It says type the co-function abbreviation in the first inbox, type the angle measured in the second inbox. Oh, this is not what we needed to do for this problem, because this question, I didn't read the problem before I jumped to the solution. It says, write the function in terms of the co-function of a complementary angle, which means cosine and sine, they are complementary, like co-functions, they're co-functions, and 15 degree will be replaced with 75 degrees. So cosine 15 is always equal to sine of 75, because cosine and sine, they are co-functions, and 15 and 75, they are complementary angles. If you think this way, sine of 30 degree is equal to 1/2, and this is the exact same value as cosine of 60 degree is also equal to 1/2. So if angle is adding up, if two angles are adding up to a 90 degree, sine of the first angle is always cosine of the second angle. And this is what you're gonna do with number 5. For number 6, we have a different question that we're gonna evaluate cosine s plus t and cosine s minus t. And we just went over this problem with the slide. Before you put these values into the formula, you have to find a cosine value and cosine s and cosine t using the triangles. So you will need to draw a right triangle, and then you need to place your angle s. And for angle s, sine value is 3/5, so opposite side is 3, hypotenuse is 5, so that makes the adjacent side to be 4. So you know that cosine of s is adjacent over hypotenuse, and I have to just check the sign. And how do I check the sign? It says that s is in quadrant 3. In quadrant 3, this is where quadrant 3 is both cosine is negative and sine is negative, so cos s will be used as negative 4/5. Similarly, we're going to draw a triangle for now angle T. You can place the T in either place. Its sine value is 5/13, so its opposite side is 5. Hypotenuse is 13, so that makes the adjacent side to be 12. So because this question only gives me the sine of angle T, I need to also find the cosine of angle T. Cosine is adjacent over hypotenuse, so we will need 12/13. And then T is in quadrant 1. So quadrant 1, everybody is positive. So this is going to stay positive. Now we have the sine of angle S, which is the first one, and sine of angle T. And we have the cosine of S and cosine of T. And we can apply the formula for cosine of S plus T and cosine of S minus T. Use these 4 fractions and we will find the answer. 7 and 7 is pretty much the same. Using the triangles, you're going to find the sine of angle S. Just pay attention that this time you're lucky because both of the angles are in quadrant 1. Quadrant 1, everything is positive. And then you're going to draw a right triangle for T. Its sine value is given, so you can find its cosine value. If you find the formulas for both of these two problems, you can plug in the values and you can find the answer. For the last question here, it's a proof problem. We're going to verify that cosine of pi/2 plus x is always equal to the negative sine of x. Rewrite the expression on the left using an appropriate identity. So we have a formula to rewrite this because this is the sum of cosine, which we can write as cosine of pi/2 times cosine of x minus sine of pi/2 times sine of x and this is called sum identity for cosine. After we finish this first line, we're going to simplify both the terms obtained in the previous step. So cosine of 90 is 0. Since this is 0 times cosine of x, which is simply a 0 because 0 times anything is just a 0. And sine pi/2 is 1. So 1 times sine of x is just sine of x. And 0 minus negative sine of x is just equal to a negative sine of x. So for space number 1, these are your options that you needed to choose from the homework on the drop-down menu. and you're gonna choose that it is the sum identity for cosine for number one. For the second space, this is not definition of tangent or definition of sine. It's simplified completely for two, and that's how we do 5.3 here.